So hello everyone. So welcome to ceadar.ie project season 2 and welcome to our brand new course of Power of Graph Convolutional Networks, Mastering Graph-Based Machine Learning. So let's get started into today's session. So today we're going to discuss about recommendation system engines here. So we are in our 6th class and let's start. So before starting, let's go on to a recap from our last session, what we discussed in a brief note. So last week we discussed the Monday session, we discussed about like a type of recommendation systems. So we did talk about like the collaborative filtering, content-based filtering, hybrid systems, context-aware recommendation systems. And we did also talk about like different types of collaborative filtering, the user-based filtering and item-based filtering. And we talk about the hybrid systems, which is like a combination of both collaborative and content-based recommendation systems. And we did talk about like context-aware recommendation system. So context-aware recommendation system is basically it focus on like third dimension, basically the location, the environment, to in order to get like a three-dimensional one of an entire perspective. So we had a brief overview of about this. So in our start, we did speak about like what and all challenges are being faced in like collaborative filtering. So we came to know about like cold start problem. So it is like basically it does not have like any prior or historical data. And there are like two different types of cold start problems we did discuss. So one is a cold start, a new user cold start, and like a new item cold start. And we did spoke about like how do we need to overcome these challenges. So for that we had like three different approaches. So one is like content based recommendation system, hybrid based recommendation system, and contextual based recommendation system. So this were our like a brief from our previous session, and we did talk about like different types of applications being used. It can be like e-commerce platforms or like movie streaming platforms, music streaming platforms, or like news agencies, social media platform, or like travel agents or accommodation booking platforms. So let's jump into like our today's session. So in today's session, we'll be talking about like the remaining what all like recommendation systems are there and their examples, applications, and finally with like a small demo of collaborator filtering using our within our like previous build chart graphs which we build. So I'll be using our the same around Mary Love story, and in the next session you guys will be like having like hands-on session of implementing the exact of the replications which we are doing right now, and we're gonna touch about like graph neural networks as well in our next session. So let's start with our recommendation system. So that's like types of recommendation systems in the continuation from our previous session. So this is a continuation basically. So basically we had like a talk about like 10 different types of recommendation systems. So in that like we did focus on like a couple of recommendation systems in our previous session. So in this session we're going to talk about like session based recommendation system, matrix filterization, factorization machines, temporal and sequential models, and reinforcement learning. So let's see like based on this content like I think like we can focus only like 2 to 3 right now because of it has like too much lengthy and verbose content. And I'm also going to show you like a small demo for collaborative filtering using Neo4j. So let's jump into like a session-based filtering recommendation systems. So in general, the session-based filtering recommendation system, which talks about the individual users or the individual perspective, his own sessions. Either he's going to have the web sessions or like application sessions or anything. So his data is stored in like in a server background for a temporary purposes. Though with those sessions, so it can be either like the user's information will be like completely like anonymized, and there'll be no much in perspective details as per like a GDPR rules and everything. But for that at that moment of the time, so it for their personalization and like for their like personal benefits and everything. So these sessions are being used, and these sessions it can be like a form of anything like clicks or searches or like results or like whatever we are going to add into a cart or our basically our like entire like program starts from we need to purchase means like at the time of when you join into the website or like when you log into the websites and each and everything, your each and every activities are being like monitored in the session. So based on that session, so it grabs to your like attention of clicks, searches and results, and thereby it feeds into a server, and thereby it gives you like a personalized recommendation system on different types of products. Either if you clicked on a product of like a Amazon uh bags, so kind of, so obviously you'll be getting like a most occurrence of bags or like most rating bags will be viewing. So that's the main context of like a session based filtering. So that current session is being kept in hold, and it's being used and reprocessed by the recommender engine, and finally it gives a list of recommendation systems. It can be bag or like any other articles or products or users. So let's talk about how a GCN can be applied using a session-based application recommendation systems. So in general, we know about like what's a graph neural network and how it looks like and how it's been here. So here, in context of session-based recommendation system, the each and individual sessions of a user is made into like nodes and edges, and then these nodes and edges are being basically these nodes and edges are like more or like less, it's like a results or a clicks or a searches or whatever it's added into cart or the whatever the item listed. So whichever we are viewing, it's made into like nodes and edges, and then it's being converted into like our graph formatted. Basically it's we gonna convert into graph format data, graph structure format. Once the graph formatted is being done, a graph representation of sequence of events in a user sessions based on the personalized information also being added to it. Once we get like a graph structured format of the data, so next come into our main important thing is to do like our algorithm here. So our we will be computing mostly the nearest neighbor algorithm. So the nearest neighbor algorithm, which calculates the different types of similarities and scores between the nearest nodes in the graph. Once the nearest nodes are being calculated, then immediately it's then forwarded into a session properties. So here we will be using like in advanced like our machine learning algorithms here. So based on different items and based on different graphs and based on the nearest neighbor score which we received, and finally based on this the similarity scores and the relationships and the specific values which are stored based on their properties, it finally gives us a recommendation system. So, at the final moment, we'll be considering the current time as well here. So, what time of the person is being logged in? So, what is this like the individual items which we hold, and the similarity scores are being found, and then it gives a list of recommendations for the user. So that's the like on an overall picture how well a session-based recommendation system is being used in a graph neural network. So let's move on to like how and in depth about like a session based graph and how it's being formed. So basically let's talk about like a what's a session graph. So in the screen which you're seeing, that's a session graph here. So basically a session graph is nothing but user interactions. So each user interactions are being notified here, and based on the user interactions, we'll be using a different session IDs, their events, their clicks, the searches, and everything. So here you can see a user is registered here, and since this is like a, for like a multiple people and everything, so each based on the person login, so their information is being stored. If a person who's like as a guest login something, his information will be stored, but it registers based on the like a logs which has been done previously. Why? Because you need to reconfirm whether the person is like a real user or like a fake user. Once the users are registered, so next important thing is like to notify the sessions. What are they like where they, whether it contains like or like any other filtering which he is doing or not. So each and everything is being notified here. So this is the place where after the session, the each and every interaction is made into a node, and each and every representation of interactions being given here is related to in terms of like either it's like a views or clicks or buys. So a user will be having like a more than like one interaction that's in common. So whatever the pages he is viewing, so that's also one interactions, and whatever the items he is viewing, that's also considered as one interaction. So based on the multiple interactions, the graph is being generated, and once the graph is being generated, so it contains like a different set of features in it, and different set of items in it, and different set of search results in it. So these are mapped into like nodes and edges based on like a multiple based on their properties as well. Why? Because a person will also do a filtering of specific categories. So now it comes to like edge relationships and like a node relationships here. So once this completely done, the each session information is being aggregated and their list is being considered. So basically, this is the session graph. Yeah. So basically, this is the session graph, how it looks like a real-time situation. So this is the real graph where Microsoft or like Amazon, they uses in their production environment. So now let's talk about like how session-based recommendation system have edge over other recommendation systems. Basically, in session-based recommendation system, which offers like a several edges in pros, I would say. So because it considers the user's specific preferences, and also like a usual yeah, and also like a user can generally he can change his mind, and he can change his preference as well. So now we are considering his preference as a main important key here. So that's the biggest aim in like a session based recommendation system, and that's a biggest the previous, right from collaborative filtering, content based filtering, hybrid based filtering, and content based filtering. So now let's start like what is the difference between them. So generally, the collaborative in environment. So basically, the here the session-based filtering, this can also combine the collaborative filtering. It can also combine the content-based filtering. It can also combine the hybrid-based filtering, and also it can combine the context-based filtering. So if we combine these four different recommendation system on top of our session-based recommendation system, so that's considered as like a top-notch recommender engine. So these are like specific type of engine which is e-commerce platform, and in Spotify and in Pinterest basically. So so intent. So in traditional recommendation system, which struggle to capture the short-term user intent because it does not contain the user specific information. Here, the session-based approach focus on immediate context of a user interaction, and thus it gives us a more accurate for recommendation system based on current user activities here. So So next one is like a real-time adaptation. So our session-based recommendation system can adapt to users based on their the real-time preferences. Say for example, a user interacts with the system, and instantly he will be losing interest of it, and he'll be making another interactions, and thus he'll be much more interested and tempted towards that interaction. So here our session-based recommendation system observes this like it changes the phenomenon, how a person is like a more interactive to a, like specific object items or not, and how well he is interacted to another set of items. Now here our session-based system will consider only his time he spent in like a specific type of items if he's going to search in an e-commerce platform, or he's going to stream a specific type of music much more interested than a different artist. So here it is completely based on like a real-time perspective of a user within that specific time limits. So next is like a dynamic user behavior. So as we said earlier, like it's completely based on like an individual context and solely based on his interactions. And here we are not considering any of his like historical data. So we won't be using any of his like a past historical data or past historical transactions or nothing we'll be using. At the moment he logs into like a website or like at that session, we want to consider only the time he spent in that specific login duration and logout duration. So next important thing is like our session-based recommendation system reduces the cold start problem. So we all know aware about like what's a cold start problem. So here, how a session-based recommendation system can address the cold start problem, let's discuss. So here, the biggest thing is like there is no or like a limited data of like new users. And by considering the session, the exact his interactions or like the level of suggestions which he uses and level of the most likeliness which he uses. So now that makes into like a sparse matrices is being done here, and that's the main aim here. And here we don't basically use no long-term historical data or long-term history of transactions. That's the biggest advantage of our session-based recommendation system, and it can overcome a cold start problem. So next important thing is like it can have a sequential patterns. So our session-based recommendation system can capture sequential patterns within a session. So allowing them to understand the order in which the interactions with the item. Say for example, if we gonna order like a school bag, so we will be like viewing a school bag and suddenly we'll be looking to like a trolley sections or like a suitcase sections or something like that. So now the individual person context is being completely shifted from one item to another item. So this is a sequential information is crucial for making contextually relevant recommendation systems. So if this sequence is like lapsed, so he will be leading into like a different recommendation system. So if it is related to a different or like a negative item, so it directly implicates the revenue of an organization, and it cut down like a major chunk of revenues either for like Amazon, like website, like e-commerce websites or like or any other websites. So next important thing is like our privacy consideration. Since all were aware like they are using our current sessions. So current sessions is nothing but our valuable informations. So what is our user login ID, um, our informations are being stored in like a server, so it should be handled in a like a very in a good manner, and like it should not go into like a hands of like some malicious persons or like a fraudulent people. So here we'll be focusing on like a short-term interactions, so we will be having like a more privacy friendly compared to other different long-term historical data observing recommendation systems. So here it considers only like the short-term like a sessions ID, and once it's completely done, this session ID is completely erased here automatically, and thus makes us much more safer and like privacy concerns. So our next important thing is like it is applicable to like various domains. So, as we all aware, like basically a recommendation system can work with like multiple domains. Either it can be like an airline booking system or a e-commerce system. Either it can be like a streaming medias, or it can be like a news agencies, or like study portals. So basically, it can switch on to like a different dynamic environments over a short period of times, and it can easily able to adapt it, the different environments with no much of data for training. So basically like session based recommendation system, so it much and so with a recommendation system that reflects his or her own preferences. So based on these preferences, our engagement will improve. So once the engagement improves, generally our items for our viewability increases, and thus makes us to get purchases more, and thus by increases the revenue of organization. So this can be like making us to buy much items compared to our like planned items. So here, that's one point I would like say it's kind of like a negative in sense of like making you to buy much than planned one thing, or multiple items than a planned one thing. So we are in a discussion regarding like how a recommendation system works, and like let's think in that perspective. Yeah. So next important thing is like it's efficient for temporary interest. So for example, some user interacts with the temporary and temporary informations. So now these temporary informations are captured in a Excel, and then it's stored in a short live preferences, ensuring that a recommendation system relevant to our interest and within the course of the session. So after this, the session terminates, the search history will be like deleted, and it won't be much useful in terms of recommending the items. So that's the biggest advantage in terms of like session-based recommendation systems, and also it aligns with like privacy concerns. So, as I said earlier, so session-based recommendation systems are like effective for unplanned purchases. That means like it makes us to buy like our based on our interest. So automatically aligns with our search patterns, click patterns, and like purchase patterns within the session, and it boosts our chances of buying items and makes the recommendation much more stronger compared to like a collaborative filtering, content-based filtering, hybrid filtering, and context-based filtering here. So let's talk about like in detail about like what all the applications are being currently used in session-based recommendation system, and how it is different from other recommendation systems. So in session-based recommendation systems, we can see like a different domains is there. So basically, they are based on like a short-term interactions, and some of the platforms are like e-commerce platform. Say in an e-commerce platform, let's talk about a scenario when a user is browsing an online store. So now the recommendation system is views the current user sessions and considers his item viewed in a cart, or like liked, or it's being searched multiple times, and that's how it recommends an item. So this and all information which we discussed earlier, I'm just gonna reiterate it. So next is our content-based streaming platform. So when here also when a user explores a video or music platform, so that informations is being observed from like current session information, and then it's consumed directly, and given the recommendations is being processed. So likewise, so based on like a different articles is being observed, our recommender engine is much more like in sophisticated and gives like exact news articles which are like recently viewed by you and most in a sequential order. Similarly, it gives like suggestions for like a social media platform, and also like based on like comments or shares, or most likely to connect with the new friends or not. So similarly, like for like different travel and accommodation bookings, so we can consider like based on our session cookies. So what are the plans we are looking for, or what are the places we are generally viewing for booking, or like different destinations, so or like different packages based on user sessions is being observed, and here the important thing is like the specific search, the keyword search is being observed. Based on the keyword search is being observed, and those the time of interaction spent, the travel planning and accommodation booking is being suggested. Similarly, different types of it can be used for like our restaurant and food delivery by based on our choice of taste of food. Either it can be like different cuisines and everything. And finally, it can be used for like in gaming platforms. So different types of games is being suggested, and based on the suggestion of games, the new games comes into our recommender, and different based on different challenges as well. So that's the general overview of like a session based recommendation systems. So now let's jump into like a matrix factorization. So matrix factorization is a technique which is commonly used in recommender system. So which used to model the user interactions and make a specific personalized recommendation system. So that's the biggest core idea here. And as you are aware, like basically the recommendation system, the goal is to give like personalized opinion. So now we are discussing in different types of recommendation system, how better is from the previous recommendation system, and like what are like the hierarchies there, and what how easily they identify the hidden patterns, and what is the specific preference of individual users are being identified. That is the important key point in the modern recommendation systems. So in modern recommendation systems, which are considered like anything which is above the session based, like filtering, so these are considered as like a modern like recommendation systems. So let's jump into like a different types of matrix based factorizations. So the matrix based factorizations, they are like four different types. So one is like a user item matrix, and next is like a latent factors, and matrix reconstruction, and learning latent factors. So let's jump to like each and everything. So generally, what's a user item matrix? In a recommendation system, a user item interactions are often represented as a matrix where rows correspond to the users and columns correspond to the items. And the entries represent the user items. For example, if we consider like a movie as an example, the ratings, the individual clicks, or like a movie purchase history are being stored here in like individual columns and everything. So that's how the user item matrix is being done. So if we consider like a latent factors, so in matrix factorization, which decomposes the user item matrix into much more in a lower dimensional in perspective. So one we can say it's for a user, and another one we can say it's for items. So each row in a user matrix and each column in the item matrix represent latent factors. So these are like a vector representations and much more useful in terms of our graph neural networks. So next important thing is like matrix reconstructions. So generally the matrix reconstruction is nothing but a user item matrix. So which has like a multiple types of capturing in it, multiple latent factors is being captured, and it contribute to the user item interactions. So here we are considering only like a multiple interactions here we're considering. So finally, we will be discussing about like a learning latent factors. So learning latent factors is also a type of like a matrix factorization, which is typically done for minimizing the difference between the actual user interactions and the reconstructed values, which we did using optimization techniques like gradient descent, or like a different like a distance which we can use. So that's the basic of like learning latent factors, and these are like important basics for matrix factorization, which we gonna use it in later stages. So now let's start with the example of like a matrix factorization, how a matrix factorization can be done. So let's dig a bit about it. So let's consider we have like 5 different users are there, and and there's like 5 different movies are there, and each users gives a rating for a movie. So now how can we define the user item rating matrix? So basically user item rating matrix is the first one, so of a basic matrix factorization. So let's see how we can represent. So as I said earlier, we have a table exactly here, so which has like 5 users and 5 movies. So now we are creating a sparse matrix here, since no every user ratings have like a every movie in it. So and like no like entirely like 5 different users, they opt their own specific rating ranges from 1 to 5 here, and there is like no person that likes or like dislikes the entire movie here. So that's a way of like rearranging the matrix here based on user item rating. So this is the user item rating, which I said earlier. So we have the table representing the different users here, like 5 different users and 5 different movies. So next we'll be like talking about like a matrix factorization. So here the matrix factorization, nothing but it undercovers like a different patterns when the in our like rows and columns, and it understands the different preferences which is being there based on different users and the ratings for the different movies. And then we apply like a matrix factorization technique, and thus it decomposes the user item matrix into latent factors. So once this is done, the each individual interactions of our users and movies are led into like a sparse matrix handling system. So once this is done, the next we'll be focusing on like sparse matrix handling. So here, nothing but like in a sparse matrix handling. So we are going to do like a factorization. So we will be filling like a missing values, like a null values. So, or like a nan values, whichever is like empty, we're going to fill it with the zeros. So basically, once we fill with zeros, so which allow us to represent the sparse matrix for subsequent calculations for our latent feature discovery. So in order to find it like a rating, and like in order to find like different features and uncover the patterns, so we need to handle the missing data here in terms of putting into zeros. So now let's talk about like a latent factor discovery. So latent feature discovery. So here the matrix factorization helps us to relieve the important features that represent the individual user preferences and their own specific and personalized characteristics. Say for example, here, no, we can it reveals much more about like a movie characteristics and individual user preferences here, and each and different characteristics are being observed in this matrix format of latent feature discovery. So with this, on how can we like proceed with other like in terms of a prediction. So let's talk about like how can we do a prediction. So let's predict for user 4 on a movie 4. So what is the like next steps in predicting how the prediction is being happening here. So now here we'll be using a basic of like a collaborative filtering method. So which is being generally applied in terms of our matrix factorization, which understands the similar preferences similar preferences of user 4. So in a user 4, he has given a rating for movie 3 is only 2. So now so we're gonna find how the collaborative filtering leverages the discovery of latent factors to find users whose rating aligns closely with those of user 4. So in user 4, so like whose rating is much more will be matching, that's we're gonna find it. So in our naked eyes, we can it is very visible that like for movie 3, the much more closing is like user 5. He has given a rating of 1. So that's the result from our IS perspective, and let's see how like in terms of machine learning perspective it works. So let's see like how a similar user rating for movie 4 is done. So let's focus on a user who have rated movie 4. Okay, so as so among those identified for movie 4, we can see that the user 4 does not have like a rating for that movie. So here, like his individual perspective for movie 3 is alone considered, and a movie 4 is not considered, but for movie 5 is again considered. Why? Because he has given a similar rating for movie 5. So that means the movie 3 and movie 5 are much more related in terms of his perspective and his personal choice here. So by aggregating the ratings of similar users here for movie 4, we can make a prediction on whether the user 4 would like that movie or not. So here we can say like based on a movie 4, and user 4 does not like the movie 4. And thus the prediction is based on our assumptions that user with similar taste are likely to share the opinions about movies here. So that's the way of interpretation. So let's see our understanding how it's being is worked. So, so based on our understanding, so what we can tell is like, if a user like gives high rating for a movie 4, that means like it's likely that user 4 would have enjoyed that movie. Similarly, if a user who has given like a lower rating for movie 4, that means like the movie 4, he did not find that movie for like a much more his choice of interest, his not his preference of choice and everything. That's the way of like our interpretation and understanding, and that's how the matrix factorization also it works. So now we have calculated like examples and everything. And how can we evaluate this in terms of our machine learning perspective? So generally in machine learning perspective, so this we can see like this is a rating. That means like these data points are in numeric format, and we generally use like a different set of matrices to measure this. So one is like a mean square error, and next will be like a root mean square error. So these are all like this evaluation criteria that asserts the model is much accurate or not, or it can further move into like improvement stages or not. So let's talk about how better is our like a matrix factorization compared with all other algorithms. So our matrix factorization, like which uses like a core concept like collaborative filtering, and it combines the computation complexity of like a matrix factorization, and thus it gives a recommendation system based on personal perspective and choices and everything. So here, so this is very important thing note. So it gives like a personalized recommendation approaches, and it is based on like and also it provides like tailored suggestions for a movie which we saw. It can be like a user has like explicitly rated the movie or not, and it aligns with his choice of interest, and thus it gives a recommendation system. So basically, this process makes us to enable more understanding of user preferences, and making it to like making possible to give like a different sets of recommendations for his items or contents or like different products which we can use. So that is the biggest advantage in like our matrix factorization. So let's jump into our small demo now. So basically, our demo will be like, how can we use like a collaborative filtering? So based on our Aran and Mary love story. So now let's talk about like Aran and Mary love story, and how can we use like a collaborative filtering? So on them, so let's think of a situation. So which will be much in terms of better for us. So here, let's see how our graph looks like. So Aaron likes to cook biryani, and Mary loves to eat that. Okay, kind of. So now let's come up with the idea. So so let's see how we can utilize in terms of Aaron and Mary. So basically, let's see how we can find a potential friends for Aaron based on common interactions. Um, so let's think about different products. We do have like purchased products, we can say, and cooked items, we can say, or cooked favorite foods, or different friends. So let's start with the coding of that and see how the collaborative filtering works. So to find a potential friends for Aaron based on his common interest. So let's match first user. Let it be a person, and his name is Aaron. Aaron. And Aaron. So we need to have like his age. So that means like it should be friends. Relationship user is friend. So now let's talk about what he has purchased as well. And purchased, or you can see I'm a cook. His favorite food. Yes. So now let's say about like a common interest which he has. And okay, it should be done in a full. Okay. So now we need to use a where not query. Where not that specific user. User should be small. His relationship is friends and their common interest. And use a common interest. Oh no, we got it. So what we need to return? So we can return the friend name, kind of. That will be much better. Friend dot should be, yes, friend name. So how can we name it as he's a potential friend? Yeah, then we can leave as potential friend. So we did name as a potential friend. And next important thing is like his common interest. We need to write about it. So for that, we need to do like a collect key. So collect key, it generally gives a distinct. Yes. So it needs to distinct the common interest. And common interest in terms of the person. Who is the most common interested person for him? For Aaron. We need to have a name. Okay. Name. Yeah. So as common interest. So now what we have done, we have did a match of the user, that's the person, he's Aaron, and the relationship is friend. And here we gonna talk about like either he has purchased or cooked or favorite food for his common interest. So common interest in the sense like the friend who is much more common in terms of like sharing each and everything for Aaron. So either he should have been purchased, or either he should have cooked, or he should have like given like a surprise, or he should have given a favorite food. So I think so. Is there any guess for this? What will be the answer? So based on the graph, you can see it. So Aaron is here. He is the individual user. So basically, Aaron is friend with different people, and now you can utilize this opportunity to see like Aaron who Aaron for whom did he cook, or for whom did he purchase some stuff or not, for whom did he like preparing the favorite food, kind of. So who's is the more common interest here? So that's gonna find. So what's the guess? Any guess here, guys? Any guess? So it should be none other than Mary, obviously. Why? Because Aaron is the basically friend with Mary, and then he has purchased. So he has purchased. Then Aaron has cooked. So he has cooked as well. And Aaron has like a gifted like a favorite food. And like for Mary. So I feel the answer should be Mary. Okay, there is some error. Let's see what's their interest variable.
Rupesh, hi, how are you? I think
Yeah.
there's a typo in common interest of second line in the middle of the common. Yes.
Okay. Yep. No, no, no.
No, it's it should be N, not
Yeah. Yeah. Common. Yeah. Let me recheck that. Okay. Contrast. Okay. That's fine. Again, variable friend is not defined. So let's debug this code again. So the user person and friend here typo. Cool. Yeah. Yes. So we got the Mary and the common interest is their relationship. So what is the common interest? Is the biryani. So this is how a recommendation system is being done in terms of collaborative filtering. Yeah. So now, so we got this information as like biryani. So how is being consumed in terms of front end? So we have this in like a JSON format, and it's very easy to process this JSON information and key value pairs, and then we can fetch this within like a front end. Yeah, that's much more in terms of easier. So that's how a collaborative filtering accommodation system is being done and realistically being used in large scale companies. So I assume like the collaborative filtering large scale companies, they don't use to like a maximum level of implementation, but for like for immediate searches, so it's being used here. So that's the one small example I just want to give right now. So we have any queries?
Um, yes, I have a question
Yeah.
in terms of the code itself.
Yeah.
So, it's written that we have to match
Yes.
Aaron with any of the common interests, but then
Exactly.
it's also written where not user in the friend of common interest thing. I mean, I'm just reading it out. The line which starts from where not user,
Okay.
the relationship friends with the common interest. So that implies that the common interest should not be a friend with the user, right?
So here like yeah so first what we can do is like, so let's go with directly with like line number 2. So line number 2, what it does is like it first filter out the nodes where the common interest is already connected to a user, so via a relationship called friends here. Okay.
Mhm.
So now, and also it ensures that like the common interest is not the same as the user. Okay, so again, here what it is doing in order to avoid a mismatch, again a user is being given here. So user in terms of he is the Aaron here. User is the Aaron here. So here what we are doing is we are like avoiding like a self-matching. That's the big thing which we are doing right now in this line. And the next line that it returns our like a friend name, and then it returns like a common interest name stuff, and that's it. Yeah.
Yeah, I mean, I'm okay with the query which is after the and, but I'm still talking about the second line of the code where not user, friend, common interest. So just that part of the query, that implies that the user should not be friends with the common interest, right?
Yeah, exactly. So
But then
so
if we look,
here uh so what it looks is not with the friend something, not like that. It is basically what it looks for is like the not directly connected, that is being looked here.
yes, yes, as a friend, right?
Yes, yeah.
But then if we look at the graph, if you could scroll down a bit, please. Is it not like there is a direct connection between Aaron and Mary as friends, right?
Yes.
So
So
how?
it is being connected as a friends,
Yeah.
but what is the difference between is like, so Aaron, we are not explicitly giving it's Mary. So Aaron is being like a friend with like multiple people here. So Aaron is being friend with like multiple people.
Mm-hmm.
So that's how it's being linked here in terms. You got me?
Um, yeah, I mean, I understand that Aaron is friends with a lot of people, but he's also a friend of Mary, or was,
Yeah.
either or. But then when we look at the first line of the code, we are basically finding the relations which are either he has cooked for or purchased, etc., etc.,
Yeah.
which leads her to Mary. But then when we are putting the second clause, which is where not Aaron is a friend with that common interest, Mary should not have been in the picture then, right? No?
Um,
Because we are putting that clause that they should not be friends, but here in the graph Aaron and Mary are friends.
somehow it makes sense for me, but so in terms of like our explanations, so we need to look up again. Say for example, so the what's the clause of like where not. So as you said earlier, like a where not. So it ensures like common interest is not directly connected to the friend of a user. So but here it is directly connected.
Yes.
And guess me how why it is giving. Just give me a guess.
Well, if I really have to, it's probably because there's an and clause. So both have to be.
Exactly. Exactly. So here we are using and here. So this is the symbol of the and here.
Yeah, I just realized while I was speaking.
Yes. That's the catch here.
Mhm.
Yeah.
Okay. Okay. Got it. Thank you.
Nice. Yeah. So have any more questions, notes? Kindly let me know if you have like any more queries. So in our next session, we'll be like implementing some collaborator filtering based on your personalized graph in our like lab session. So where I'll be giving like a personalized monitoring each and every people as we generally used to do in a breakout rooms and everything. So if you have not like created like a 20 different nodes, and just please take this opportunity to create it, and let's see on Monday by 3 o'clock. So if you have any question, please let me know.
Thank you, Rupesh.
Thank you very much. Yeah.
Yeah.
Thank you.